All right, today we're reviewing for the cumulative test, and there's 3 parts on the cumulative test. The one that I think we need to worry about the most is the ones problems 9 through 14, which is about properties number 2. So I'm turning to problem number 9 on the packet, and it says to find this point, number 9. It wants me to find negative square root of 3, comma, 1, negative 1. And I tried to pound into your head that when they give you a point like this, they're not just giving you a point, they're giving you 2 sides of a triangle. So where is negative root 3, negative 1? It's down here somewhere. How do I know that? Because I know it has to go negative, hold on, I missed that just a little bit. There we go. It has to go negative and negative, so that means I must be in quadrant 3. I have to go negative and negative, so it must be down there somewhere. And I'll specifically make it right here. And I'll say that is negative root 3 comma negative 1, and that just gave me 2 sides. 2 sides of this triangle. It gave me these 2 sides. This side right here, that's the x, and that's the first one, negative root 3. And then this way, negative 1. But the tricky part is trying to figure out what kind of triangle that is. It's either 30, 60, 90, or it's a 45, 45, 90. Do you recognize if you have a 1 on one side and a square root of 3 on the other, which one you're probably in? Probably the 30, 60, 90. And this, therefore, must be a 30-degree angle. But the 30 degrees is not the right answer. Let's see what the question is. Give the smallest positive angle measure in both degrees and radians. I would have a lot of kids that would argue 30 is the small one, but that's not the point. The point is we're here, and we're trying to find this angle. The reason they said positive is because it's true. If you wanted to go negative, you could go this way, but they don't want that. So it's the smallest positive angle, that's this way. So that answer's got to be 180 plus the 30, and therefore what? 210. Now, why would you be marked wrong if you said 210? Because it wants it in both degrees and in radians, and therefore I got to change 210 to radians. And the reminder on that, multiply it by, in this case, what? Pi over 180. Very good. Cancel the degrees, cancel the zeros, and then, so you're saying 3 goes into both of them, 7 and 6, 7 pi over 6. I agree. So 210 and 7 pi over 6. All right, so for problem B, you just draw yourself a nice little triangle, figure out where 1 comma negative 1 is, and that's 2 sides of a triangle. Once you know it's 2 sides of a triangle, you can say, oh, if the 2 sides are 1 and negative 1, I bet that's a 1, 1 root 2 triangle, and therefore a 45, 45, 90 triangle. And then you just try to figure out what the actual angle is, because if you have a 45-degree triangle and it's like right here, then that's not going to be 45. It's going to be all the way around here. All right, moving on. That's for number 9. Let's look at number 10. Whole bunch of them like that. Obviously, you must be needing to be pretty good at those. Let's do part B, cosine of 7 pi over 3. Number 10, B, cosine 7 pi over 3. Well, the first thing I want to know is where's 1 pi over 3? Do you remember on this circle, which is all students take calc, where 7 pi over 3 is? I don't know where 7 pi over 3 is, but I know where 1 pi over 3 is. That's 1/3 of a pi. That's 2/3 of a pi. That's 3/3 of a pi. Know what I'm doing here? 4/3, 5/3, 6/3 was right there. 6/3 is same as 2 pi, right? So 7/3 is back up to that original 1 right there. That's where 7 pi over 3 is. Because it went all the way around and then stopped right there. Okay, now I get to draw a triangle that goes with that. So I'm going to assume for a moment that they're going to probably need the side lengths on this. So if this is 1/3 of a pi, it's also known as 60 degrees, and therefore this must be 30, and therefore this must be 1, 2, and the square root of 3. Now let's see what I might need that for. Evaluate. Okay, evaluate. I've already got the angle. They must want the sides for that. So the sides would be for cosine, ca adjacent over hypotenuse, 1/2. Raise your hand if you already had that. Okay, awesome. All right, let's move on to problems like number 11 is a lot like that problem 9. You just got to draw the triangle and show where -3, -5 is. And they just want all 6 functions. So you find sine of that angle. So once you've drawn a triangle for number 11 and figured out the third side, which will be pretty easy, then the 6 functions will be pretty easy. So get the triangle drawn, and number 11 is easy. Okay, number 12. Do you get that that's telling you that there's probably 2 answers? How is it saying on number 12 there's probably 2 answers? All angles. Find all angles. And then they say between 0 and 2 pi. So that's a hint there's probably 2 answers. So let's try to do 12a. On 12a, it says tangent is -√3. Tangent of theta is -√3. And I want to put that over 1 because I always like to have 2 sides. So now I'm going to figure out, where is tangent negative? All students take calc. Well, it can't be here and it can't be here because those are places where tangent is positive. So if tangent is going to come out negative like it says it does, then I know I must be in these 2 spots, and that's why I have 2 answers, because one's going to be down here and the other's going to be up here. All right. Now I'm going to say tangent is TOA, opposite over adjacent. The opposite side from this is -√3. The adjacent side is 1. That matched up pretty good. Opposite is square root of 3. And couldn't that negative be on the 1 instead? Just as easy if I put the negative down there. Isn't that okay? Yes, it is, in case you didn't know. And this could be a -1. There we go. So is that my answer? Well, that's my picture. Where is the answer? The answer is, what are the angles that work now? So we got to figure out that angle. And then the other angle goes all the way around to there. All right, so that angle, the green angle right there, if this is a 1, 2√3 triangle and the 1 is across from the 30, then this must be a 60. And if that's a 60, then that must be 120. And then that's in degrees, but since the directions were in radians, I better change that to radians. 120 is 2 60s, and each 60 is a pi over 3. So it's 2 pi over 3. That's one way to think of it. Otherwise, you can just do the old convert thing and say 120 times a fraction of pi over 180, and it'll convert it over to 2 pi over 3. Okay, so there's your first answer. I'll let you figure out the other answer, which is this guy down here. If this is 60 degrees, it's not that hard to figure out the math on what that has to be, and then just change it from however many degrees that is into radians, and then you'll have it. If the directions are given in radians, which this one is, then you want to give your answer in radians. If you're ever not sure, just give your answer in both. I would never mark it wrong if you gave both answers. But if the directions said, make sure your answer is in radians, and you never wrote radians, I have to mark it wrong. Okay. Remember, it was 9 through 14, so we better look at like number 13. Ooh, that kind of problem where you have amplitude, phase shift, etc. Since there's only one of those, I'll just make you a different one. What if it said this? Let me do it this way. 2 x minus pi, and then minus 3. All right. What would all those different things mean? The beginning, that's the amplitude. Don't use the negative on it, but that is the amplitude. That's called your B term. Your phase shift is when you take the 2 out and go like this. You factor it out like that, and the phase shift then, after you factored it like that, this is your phase shift, which would be right pi over 2, also known as right 90 degrees. So that's the phase shift part. This is the amplitude part. What else does it ask you? Phase shift, amplitude, range. Okay, the range is told by this, because the range of this guy is from the lowest it goes to the highest it goes. All right, and the last thing, period and domain. The period on this guy is normally 2 pi because it's not tangent. Tangents and cotangent are the only ones that have a period of something different, and that's pi. Since this is sine, it's got a period of 2 pi. But the formula uses 2 pi over b to figure out your period. And so since I have a b term of 2, this guy's period would turn into 2 pi over 2, which would reduce to just pi. Whenever you're doing sine and cosine, think about how they look. How far is that going to keep going left and right? Therefore, what's the domain? Yep, negative infinity, positive infinity. Yep. Okay. All right. And so I didn't want to do the one problem you had for number 13. I showed you one like it. So you try number 13. If you have questions, ask me. Let's see. Last topic that's on the hard test was this deal where you add or subtract some huge number of pi's. All right, and I told you that original one by doing something I knew you all would know, sine of 30 degrees, and I hope you just have it memorized. Do you know what sine of 30 is? 1/2, good. If you didn't know, you'd have to make yourself 30, 60, 90, and you'd figure out it was 1/2, and so it's 1/2. All right, but what if I do this to it? Plus 2 pi. Do you get that I'm in the exact same place I was in the first place? So therefore the answer is the same exact thing? Because if you go around this whole circle and you started here at 30 degrees and you go all the way around in your exact same place, the answer is still going to be the same. So the answer on this one would still be 1/2. What if I made it 12 pi's? Any even number of pi's means the answer is exactly the same as it was. Okay, so what if I change it to an odd number of pi's, like just pi? Then it goes over to the other side. I don't know if you've caught on to this pattern, but what happens to the answers always if you go to the other exact opposite side of the circle? It'll be the same thing except the opposite. So the answer to this is not 1/2. The answer to this is -1/2. So if you add any odd number of pi's, you're moving to the opposite side of the circle. Where this used to be, let's see, if it's a 30, 60, 90, like we were saying it was, then this is a 1 and a 2 and a square root of 3. Now it's going to be exactly opposite over here. Do you get how this has to be a -1 and a, -1 and a 2 and a square root of 3? So the sign in both of those places uses a 1 and a 2, but one of them is negative now. So it'd be opposite over hypotenuse is -1/2. Okay, so if you knew the answer for cosine of 2 pi over 7, some weird thing, it doesn't even matter what it is. Okay, and then you add 2 more pi to it, do you get that I didn't really move at all? I'm just in the exact same place I was, and therefore the answer doesn't change, whatever the answer to cosine of 2 pi over 7 is. But if I added 301 pi's to it, then the answer is the exact same as it would have been, except negative. The opposite of whatever it used to be. Okay, that's a review of the stuff on that test. I do want to give you a lot of work time, and if I stop now, I can actually accomplish that goal. So the rest of the tests, I'm going to leave to you to work on. The vast majority of kids did really well in the first and the last test, so I just wanted to cover that middle test. Need more help? Ask me individually. Come in and get help from your teacher any morning except Wednesday. And in this case, tomorrow morning is a Wednesday. So you do have 25 minutes to ask me questions right now. Okay, that's all I got.